Hey, what's up everybody? I'd like to welcome you to another JUCE tutorial. And in this tutorial, what we're going to do is take the equation for a sine wave and actually turn it from math theory into code. And this is a great tutorial if you're just getting started with digital signal processing like myself, and you want to learn how to take something that you may see in a book or on Google and actually turn it into something that you can use in your plugin or audio application. So let's go ahead and get started. So before we get into the sine equation itself, I thought it'd be useful for us to take a look at a sine wave and just take a look at some of the characteristics to see what we're actually going to do. So I've got a 1 second sample of a sine wave, and what we can do is we can actually take a look here in Ableton and just zoom in really close. And what we will find is that here you see these dots, and these dots are actually points, and that's exactly what we're going to calculate when we do the sine wave equation. We're going to calculate points over a period of time. We're at 60 beats per minute, and we've recorded a 1 second sample. So the next question is, how many samples do you think, how many of these points do you think there are in 1 second of time to actually construct this sine wave? Well, that's where we come into sampling frequency or sample rate. So if I go into my preferences in Ableton, what we'll see is that in this particular situation, my sample rate is 48,000. So what it means is that in this 1 second clip of this sine wave, we actually have 48,000 of these points. So it's 48,000 of these points, 48,000 calculations that it takes to construct this sine wave in 1 second. So that's what we're going to actually do. Another thing that I should let you know is that, as you can see, we actually have 2 channels of audio here. So we're actually playing a stereo sample of this sine wave, and that's important as we actually progress along in this tutorial as well. So let's now dig into a little bit of math theory. And what I would encourage you to do for this tutorial is, if you're just getting started with digital signal processing and with math, to not try to take too much of this on at one time. Let's just concentrate mainly on how do we take these equations and actually turn them into code, rather than trying to get the deepest intuition for what's actually happening under the hood. I think that actually comes over time, and this equation alone and the sine wave equation can easily be a tutorial of over an hour just in the implications and the areas that I understand. And there are many more areas that I don't even understand remotely. So this is something that comes over time, and I would just encourage you to take it slow. So the first thing is, going back to our Ableton program, we had the series of dots that were actually constructing the sine wave, and we asked, how many dots does it actually take to construct a sine wave in 1 second? And the answer in that situation was 48,000. Okay, so what that means is that we need to make a dot every 1/48,000th of a second in order to actually construct this sine wave. And that's all we really mean by this term that we call period, or you might hear some people call it step or time increment. It just means how often do we need to actually make a dot or calculate another dot on our sine wave. And so that's one of the first things that we need to do when we're doing any sort of digital signal processing, which is, how often do we need to make the calculation of the next point on the wave. And in this situation, or in the situation in Ableton, it was 1/48,000, or sometimes it might be 1/44,100, which is another common sample rate. Now that's going to take us to our next equation, which is the main sine wave equation, which is the one that you would see in just about any audio programming or physics book. And once again, don't get intimidated by the different symbols. That's something that comes over time, getting an intuition for what's happening. And what we're going to do is just mainly concentrate on taking this and trying to convert it into code. So to read the equation from left to right, it's the sine of 2 times pi times the frequency. So the frequency is just the frequency of the wave. And as many of you probably already know, the human range of hearing is from 20 hertz to 20,000 hertz. So that F is going to be somewhere between 20 and 20,000. And then we have this T, which is the current time, and it's going to be incremented by P. So P, once again, is going to be 1 over the sampling rate. And all we need to do is we need to have a mechanism that's going to keep time, the current time, every time that we update the wave, which means that it will go 1 over 48,000, 2 over 48,000, 3 over 48,000, until we get to 48,000 over 48,000, which is 1, and then it will go back to 1. It'll actually go back to 0 over 48,000, and then 1 over 48,000, and we'll go back up again. So all that's doing is just actually incrementing from incrementing by increments of 1 over 48,000. And then we have this this plus theta. Theta is what we call the phase. Phase actually moves the wave up or down on the y-axis, but we're not going to really worry about phase for this one. We're going to keep it really simple and just worry about sine of 2 times pi times the frequency times the current time. Okay, so now we're going to take this step by step, and we're actually going to turn this into code. So now we will go to our JUCE project, and we'll make a new JUCE project here. I'll just call this SineWave. And after I do this, I'll actually put this up on my GitHub, so you can actually take this and download it and analyze it and do what and just take a look and see what sort of things you can learn from it. So I will just call this SineWave. And we're going to make this an audio application, so we don't need to worry about putting it in a plugin. But this would be very similar if we were doing it within a plugin. I'll just put this on my desktop. And the first thing that I'm going to do is I'm actually going to make a class just for my SineWave. Okay, so in this one, I'm just going to use a header since this is going to be a small class. And I will just call this SineWave. And now we have our header file. And now what we could do is just hit the center button and do save in and open in IDE. So now we're going to open this, close all this unnecessary stuff out, and go to our SineWave class. So hopefully I'll get this right, or else I might have to do a little bit of editing magic. So first thing we're going to do is we're going to make a class. We will call it SineWave. And don't forget to put your semicolon afterwards. And then we're going to have a public area, a private area. Great. So first thing that we need to do is we need to go back to our slide here. And we will first talk about our period or a time increment, or how often we need to update our wave and make and calculate a new point, which would be 1 over the sample rate. So what I will do is I will go back to our main component, and in our main component, as you know, if you've watched the other introductory JUCE tutorials, we have this method called prepare to play, which is going to be called anytime right before our audio is going to start to play, and that will give us the sample rate that we need to actually pass on to any sort of digital signal processing algorithms. Okay, so this is something that's very standard in any sort of digital signal processing algorithm, is we always have to have a prepare to play and somehow pass on our sample rate. So what I will do is I will make a method called prepare to play. And what I will do is I will just pass in this double of a sample rate. And now let's go back to our equation. Let's make a member variable, a float member variable, and we will call it period. Okay, so I will say float period, and let's make it 0.0 to start off with. And now what we're going to do in our prepare to play method is we will say period is equal to, and we just copy this equation, 1 over the sample rate. Okay. Now, since this is a double or a float, we'll just make sure that this is a float. We want to make sure that this is 1.0 and not just 1. Okay, or else you're going to get a conversion. You may get a conversion error. Okay, so that's what we have there. Okay, so that's how we're going to determine our period. Okay, so you can see that is exactly what that is, right? Now what we need to do is go to our next equation, the sine wave equation, and now we need to do this. Okay, so let's make a method. Okay, so what we're doing is we're calculating points on our sine wave. So what I'm going to do is I'm going to create a method that is going to return a float, and let's say get next sample sounds like a good method to call this. And I'm just going to wait until I actually figure out what sort of inputs that I need for this just yet. So I'm just going to leave it blank for now for arguments. So we have to first look at our current time, right? So we have current time that's going to be incremented by p. Okay, so what we need to do is we need to have a mechanism that's going to keep track of our current time. So let's create another float, and I will call this current time. And this will be 0. This will start off at 0. And this will go from 0 to 1. So we'll go from 0 to 1 by increments of 1 over the sample rate. So what we could say is we will say current time plus equals period. Okay, so that means that our current time is going to, every time that we call get next sample, our current time is going to add by increments of 1 over the sample rate. Okay, now we need to make sure that we have some type of mechanism to make sure that once we get to 1, that it actually resets back to 0. So because of that, what I'm going to do is I'm going to say if current time is greater than equal to 1.0, current time is equal to 0.0. Okay, so what we're doing is we're adding 1 over 48,000 or 1 over our sample rate every time that we call this, and then we make sure that if our current time gets to 1 or above, then we just reset it back to 0. So this will just go from 0 to 1, 0 to 1, 0 to 1 by increments of 1 over 48,000 or 1 over our sample rate. So now we just want to actually do our sine waves. So now we need the help of a couple functions from the standard library and also from JUCE to actually make our sine wave. So what we'll do is we will create a local variable. I will actually explicitly call this a float. We'll call this sample equals, and now we just need to put our sine wave in, our sine wave function. So lucky thing is that sine is actually a function in the standard library. So we actually have a function called stud_sine, which is going to compute the sine of whatever we put inside of it, which is actually really nice. So we could just say stud_sine, and now we just need to put in the rest of our stuff. So we have 2, and one of the things to for people who are just getting started with algebra and with this math is that normally when you see these symbols and letters like this means that they're multiplied. So this means 2 times pi times the frequency times the current time. Okay, so we're just going to put all of that in. So we got 2 times, and the next thing we need is pi, which is the 3.14159 number here. And we actually have something in JUCE where we can actually use this. So this is in the math constants class. So what we could do is we call that using, so we're in the JUCE namespace, and then it's math constants. And we need to tell it what type that we want this to be. We'll make this a float, and then we will use another 2 dots, and then it's pi, like that. Okay, so a little bit tricky on the syntax, but we got there, not too bad. And what's the next thing? Times the frequency. So before I go to that, I'm actually going to do something here. So notice I put 2 here, and this 2 is an integer at the moment. Okay, we want to make sure that we try to keep our types safe. So what I'm going to do is I'm going to make this 2.0, because what I want to do is I want to return a float. So it's always good practice to try to make sure that you keep the types of your numbers consistent. Okay, so now going back to our frequency. So what I've done is I've actually made an argument for frequency, so we can actually input and change our frequency if we need to. And so what I will do is I will make frequency our next thing in the equation. And then going back to our equation again, the next thing that we need is our current time. So we had that mechanism that resets, and we're just going to put that member variable in there now. And just for the sake of completeness, we have this plus theta, or plus the phase. I'll just keep the phase as 0.0. And remember, keep this type safe, keep it as a float if what we're trying to do is calculate a float, okay? Just keep it all the same. Now what we need to do is we need to actually return that at the end, because remember, this is supposed to return a float. So we will return sample at the end. And now we should be good. So we have this current time that resets all the time. And notice the order that I put this in. Okay, there may be a better way of doing this, but this was the best way that I could think of at the time, which is that if our current time actually gets to 1 or above, then what we do is we reset the time back to 0. Okay, so this could very easily be down here as well. Okay, I actually put it above it because I was thinking, what if we stopped playing the wave, and then the next time that we played, it was actually above 1.0 for one reason or another, and so I just did it more as safety, but maybe for readability's sake, maybe this will be better actually under current time plus equals period. I'll keep it here for now though, because I know it works this way. So there we go. So now we have our SineWave class. So now what we need to do is we actually need to bring this into our main component to actually be able to play this out of our audio audio callback. So what I've done is I've included SineWave.h now in my main component, and now there's this interesting thing that we need to discuss, which is one of the most important fundamentals of digital signal processing, which is that anytime you do digital signal processing, you normally need to have one object for every channel of processing that you're doing. So in this case, we were doing a stereo setting, so something very similar to what we see here. So we have two channels of audio here. And because of that, what we need is we need two separate sine waves, okay? Or else it will not sound right and you'll get this clicking or buzzing or it just won't sound right. So what we'll do is we'll make a C-style array of a sine wave. And so the way I could do this is I will create a sine wave. And what I'll do is I will make two of those because we have a left and a right speaker. And I will just call this sine wave with a lowercase letter. I'll call it my sine wave just to make it a little bit different so you can see that there. Okay, so that's so important because we need to make sure that we actually have separate ones for each channel of processing. Okay, so actually, I'm sorry, I got my syntax wrong. It needs to be over here. So, so there we go. So now what we need to do is we need to, everything that we do to the first sine wave, we need to do to the second sine wave. And now we just need to plug in all of our stuff. So first thing, sorry, I'm in the wrong place. First thing that we need to do is call prepare to play. Okay, so we will say for int I equals 0, I is less than. So we could say 2 here. One thing that I like to do is if I'm going to do something like this, I like to actually make something that I can call over and over again rather than having to say 2, because that way, if I need to change it, I just change it in one place rather than needing to change it all throughout my code base. So what I'll do is I will make a static const expr int outputs, and I will set that equal to 2 like that. And then what I'll do is now I will set this like that. So now if I need to change the number of outputs, then I just do that in one place rather than needing to do it in multiple places if I put this magic number 2 everywhere in my code base. So now we will say my sine wave I dot prepare to play. And in here, we just put our sample rate. Okay, so that's how we're going to set our period. Now we're just going to get rid of all this unnecessary writing. We want our buffer to clear because our buffer is going to fill every callback with new information. So we're going to put that at the beginning of our callback to make sure that we don't have any junk there. And now what we need to do is we actually need to calculate we actually need to take this calculation and we actually need to put it into our audio buffer. So to do that, we will start with our channels. So if you're not aware of what I'm doing, make sure you check out my other tutorial, which I'll put a link to somewhere in this video right now, that will actually point you to audio buffer basics. So if you're not familiar with what I'm doing here, then you probably want to watch that video first. So we will start with int channel equals 0. CH is less than outputs plus CH. And there's a little bit of danger here. So we're assuming that that our number of output channels is 2. And if it was 1, then there may be a little bit of danger there. So I would normally put checks just to make sure that the number that our outputs that we've assumed to be 2 is indeed the number of outputs that we have in our output channel, but I'm just going to keep it simple for now. So now we're iterating through channels, and now we need to iterate through our samples. So S is less than buffer to fill, buffer, get num samples, plus plus S. And then now what we need to do is we actually need to grab our right pointer for our buffer. Okay, so this is stuff I've covered in previous tutorials, so I'm not going to go through it again, but what we could do is we're going to make this auto, I will just call this, I don't want to call it output, so let's just call it out buffer equals buffer to fill dot buffer get right pointer. And here, since we're iterating through our channels, we just put that as our argument. And now I will do out buffer, since this is a like a std vector, which is our actual audio buffer that we're writing out to. And so we're going through the samples in our output buffer equals, and now here is where we put our sine wave equation. My sine wave get next, I need to do channel because we have two of these, get next sample. And then we just need to put in our frequency. So let's make our frequency, let's say 200 hertz. Okay, so that's it. That should be fine. Okay, so we'll do that. Then we'll do some minor code cleanup and little checks and things like that. Actually, one thing I'm going to do is I'm actually going to turn this down a little bit. So I'm going to take the output, I'm going to multiply it by 0.3. So that's just going to actually take the output and just turn it down a bit so it doesn't blow our eardrums out. Okay, here we go. Great, we got a sine wave. So that's how we actually make a sine wave. Okay, so a little thing that I might do just to clean this up just a little bit. You know, we have this buffer to fill dot buffer, and then we have this here. So this starts to get a little bit long. So something I might do is I might say auto buffer equals buffer to fill dot buffer. So since this is a pointer, I might do that. This just makes it a little bit more readable. There we go. And another thing that I might do in my sine wave class, sorry, this still needs to be arrow, since it's a buffer, since it's a pointer. And another thing that I might do is we need to make sure that our prepare to play has actually called, and that we've actually called this before we actually try to do any sort of math on this. Otherwise, we may have a problem. Okay, so one thing that I might do is I might use this this little tool called JUCE, just to make sure that period is greater than 0. Okay, so that just makes sure that prepare to play has actually been called and that the period has actually been set before we actually try to add it to current time. Okay, otherwise period is just going to be 0, right? And it won't actually do anything. So now we will just test that out again. Building. There we go. So that's it for this tutorial. So I hope you enjoyed this. I hope you found it helpful. It could be a little bit complicated to go through the equations and the code and everything, but if you found it helpful, please be sure to give it a like and subscribe to the channel. Also, be sure to join our audio programming community on Discord. So we have nearly 6,000 people in there now. And it's a great place if you get confused on a tutorial like this to ask questions and to get some help and to connect with other people who are into audio programming. So with that, I will complete this tutorial and I will see you next time.